We weren't around during the reign of the dinosaurs. But if we had been, we would have tried to barbecue one.
Oh, we would have gone after the big ones for sure. Humans are big game hunters. You know, the biggest, baddest dinosaurs.
Today's dinosaurs are known as birds. And around the world, recipes abound for duck, pheasant, goose, and even ostrich, and more exotic avian fare.
And so there were always giant dinosaurs and always little dinosaurs as well. And birds are the surviving dinosaurs.
Over millions of years, birds lost their teeth and grew beaks. But they still retain a lot of dinosaur-like qualities.
Wow, it's still really segmental, and it's just starting to do something up there, huh?
Yale researchers wanted to see if they could reverse evolution and turn a bird back into its dinosaurian ancestor.
And the idea is just to see how the brain case is shaped, because they are kind of close to birds.
Just took out this thing that was evolutionarily novel to birds and let the thing develop as it would have in the Jurassic.
According to Professor Bart Ongen-Buller, the closest we can come today to a T-Rex drumstick won't be an emu thigh. It'll be by gnawing on a piece of chicken.
You want a relative of T-Rex that in body and in act, you need look no further than your local farm, because chickens are actually very primitive birds. And they are predatory dinosaurs. They are theropod dinosaurs, just like Tyrannosaurus rex.
According to Ongen, chickens and theropod dinosaurs, like T-Rex, have a lot in common.
Even though the depictions of Tyrannosaurus in Jurassic Park are of a more lizard-like animal that's kind of got a long, floppy body, now we're seeing more and more that when these animals are preserved in situ, in their natural orientation, with their natural body form, the bodies of dinosaurs were remarkably bird-like. The torsos were short and very, very deep, heavily muscled, and extremely stiff. And so these animals were already walking around like birds, probably with their heads bobbing in the same way. The bodies of dinosaurs were almost certainly at least partially covered in feathers.
For decades, the only link between birds and dinosaurs was Archaeopteryx. It was a hybrid creature that lived in the late Jurassic, with feathered wings, but with the teeth and long bony tail of a dinosaur. A different fossil fragment revealed that just before the mass extinction 66 million years ago, the last toothed bird may have been an elusive beast known as Ichthyornis.
This is an animal which is a stem bird, so not quite a bird, that still had teeth in its jaws, that is rather close to the origin of modern birds, but it's not quite there yet. And so it tells us a lot about the final transitions that the bird line made toward the modern form. And what we found is that, in fact, this animal sort of has the first beak. This animal lived in the late Cretaceous, and so we find after the mass extinction, only the beaked forms survived.
None of the large, well-known dinosaurs made it through the Cretaceous-Paleogene extinction. But little dinos did. Ground-dwelling birds were the champion survivors.
They had the lifestyle that we kind of colloquially would call a fowl lifestyle. Birds that were able to make their way in undergrowth and to nest on the ground and to just live their whole lives on the ground, eating detritus, being sort of drab and unobtrusive. They were able to weather this cataclysm that destroyed forests globally. There were no trees. All the tree-living stem birds that weren't quite birds went extinct.
And this led to the evolutionary radiation that produced the birds we see in our yards and on our dinner tables today. Birds are really modern-day dinosaurs, barely once removed.
And you can see the fossa part.
Yeah, there seems to be...
Over and over and over again, what we're seeing, at least with the body, is that the kind of the pre-skeleton, the earliest form of the skeleton in birds, is incredibly similar during development to the skeleton of dinosaurs.
The scientists needed to investigate just when the embryos of dinosaurs and birds began to differentiate.
And we're looking at the transition from that very simply patterned embryonic state to the complicated, more advanced adult state. For a long time, we've known about the general way in which bird embryos form in the egg, the way they look. We've known a lot more about them externally than we have about their internal architecture. And part of that is because the inside of an embryo, we're talking about a little shrimp-like thing about that big, it's so fragile. It's just kind of, it's a bunch of barely differentiated goo. And it's very hard to examine that when you're manually dissecting something or just looking under a light microscope. That's the anterior rib.
Yeah, all these are
That's the waves of, right, yeah. One of the things in which my lab specializes is that we're able to use technology like X-ray CT scanning and microscope technology called laser scanning confocal microscopy, which lets us peer inside these embryos and see the developing tissue, see the bones as they develop, the nerves, the muscles, everything in this glorious high-resolution, three-dimensional digital framework that are digitally dissectable and can be examined in many different ways. And we're seeing into the secret earliest lives of birds.
Based on these virtual dissections, Dr. Ballar and his team were actually able to alter chicken embryos to grow the snouts of velociraptors rather than beaks.
It's incredibly close to hatching that birds gain many of their avian features and overprint the dinosaurian form that they have. Chickens take about 20 days to hatch. We see a lot of this avian-specific overprinting go on at around day 18 of 20, 19 of 20. The beak seems to be so profound a modification that it appears much earlier in development. That means that instead of altering something really late in the game, you have to go back to very early development when various genes are turning on and off and telling the cells of the early embryo exactly how to move and how to mold themselves and how to change shape. And so we looked at the ways in which the faces of birds are given instructions genetically that are different from the instructions given to something like a reptile or even a mammal like us. And what we found was that in birds in particular, there's a big area of gene expression that appears right in the middle of the face. It's this huge patch that isn't there in anything else.
His research revealed that birds' faces develop late during the embryonic stage and don't form beaks until close to hatching.
We went back to these bird embryos and we were able to take beads coated with inhibitors of these molecular signals and implant them right in the middle of the face to eliminate that bird-specific patch. So this is just when instructions are being given to the embryo about how to form. And then you have to let them go and see what the product is. Have you actually kind of rolled back evolution and recreated something reasonable looking? And so it was sort of a waiting game. But when the skeletons did develop, they ended up looking extraordinarily like those of velociraptor, like dinosaurs, and not like birds. And so the facial bone structure was transformed back into a dinosaurian condition.
His team of scientists removed the gene-driven bird-specific protein from chickens' faces to replicate the molecular activity of their early ancestors. They let those embryos grow, and the results produced a chicken-raptor hybrid skull.
When the first chickens came out with that, dinosaurian face morphotype, I was past the point of wanting it. It was like 3 in the morning, and I was just ready to see another tube of failed experiments, and I was sort of bleary, looking at this thing, and this can't be real. Am I asleep? No.
Would these dinosaurian creatures have hatched and survived?
They probably would have been viable. We didn't hatch them. There was no reason to. We were doing an evolutionary experiment. We were trying to create a dinosaur.
It makes us wonder, did T-Rex taste like chicken?
The body of the bird, that sort of stiff, short torso, that massive amount of musculature, that would have been very similar to what you would have seen had you opened up a Tyrannosaurus rex. And the muscle, that white kind of muscle form, that would have been there too. You look at the way the meat is spread out and concentrated. It's not a bad approximation of Tyrannosaurus rex.
Maybe T-Rex would have made for a delicious barbecue after all. In the meantime, we'll make do with chicken.
In a way, it's still the age of the